All right, so you need to be able to distinguish between real zeros versus complex zeros, right? Or real solutions versus all solutions. Okay, and so I want to model this with a problem. So let's say I gave you the following and asked you to solve. And it asked find all solutions. And you're given the equation 3x squared minus 1 is equal to negative 16. Okay, so I want you to see if you can find this on your own here real quick. All right, so if you tried with your TI-89, what happened? It says what? False, right? Okay, so if you think about that, false on the TI-89 means there are no real solutions. However, it doesn't say there aren't complex solutions. Right? And so anytime you have an equation, your equation will have complex solutions. Right? And so you have to be aware of those. And when you're looking at the number of complex solutions or the complex solutions, often it can be done by hand. So I'll show you this real quickly. If you're doing it by hand, you solve it just like you're finding real solutions. Okay, so we're going to isolate our variable. So to do that, we get our x squared alone first. Continue to isolate the variable. We get x squared is equal to negative 5. And now when we try to extract the square root, we get x is equal to plus or minus square root of negative 5. Okay, so at this point, you can see there is no real solution here. You can't take the square root of a negative number in the real number system. However, as far as all solution or complex zeros or complex solutions go, you can represent this using the I. And this is where the I comes into play. Because what we really have right here is we have the square root of negative 1 times the square root of 5. Okay? So the square root of negative 1 can simplify to what? It's represented by I, and then the square root of 5 stays as it is. I would prefer probably that you write the I at the end. And so if you were asked to identify the solutions for this online, you'd have a lesser solution and a greater solution that you'd have to fill in. And so you would take negative SQRT 5 times I, and the greater one would be positive SQRT of 5 times I. And so that's what your solutions would look like if you were entering these online. Now, on the TI-89, it is still possible to solve these. And the way that you would solve them is you'd use the CSOLVE function. So if you go through the process of solving, so F2, the algebra tab, and you try solve 3x squared minus 1 is equal to negative 16, solve for x. And you get the command false. So you know there's no real solutions. But there's always going to be solutions in the complex system. So all you need to do is move your cursor to the very front, enter a C in front of solve. That tells you, what do you think it stands for? Yeah, the complex solution. So we're looking to solve it in the complex number system. Hit enter, and now we confirm what we wrote here. Negative square root of 5i and positive square root of 5i. And those would be your two solutions. All right, so try one last one on your own. I'll come back to this slide here in just a second. Or I'll leave it here. And see if you can solve the following. Okay, so find all solutions for this. Again, you do need to start making sure that you read questions carefully. Questions now might say find all real solutions. They might say find all solutions. They might say find all complex solutions. So you need to be able to distinguish. Again, approaching this type of a problem, just hit the Algebra tab, F2 Algebra tab, choose Solve, enter the equation, 4x squared minus 5 equals negative 77, solve for x. You get the command that this is false. Once you see that, just go ahead and type in a C in front of the solve, see if there's solutions in the complex number system, and you get your answer to be plus or minus 3 square root 2i. Okay, so if you were entering these answers online, the way that you would enter it, the lower one, negative 3 sqrt times 2i, and the greater solution is going to be just the positive 3 sqrt to I. And so those would be your two solutions.